So I think we're about to get started. How's everybody doing today? Can everybody hear me all right? Awesome. Well, today we want to talk about the future architecture of streaming analytics and how to capitalize on what we call the analytics of things or the Internet of Things. How many people in here are struggling or actually just have something in production for streaming architecture? Just a show of hands. Okay, and for those people who didn't raise their hands, how many people are evaluating, thinking about putting something in production or just kind of, in an educational mode? Awesome. So we've got an awesome session today where we're going to talk about just some of the things that we're looking at and some of the things that we've seen with streaming architectures, and kind of, we're going to go through a little bit of the past, present, and future too. So who am I? I'm Thomas Henson. I work with Dell EMC. I'm part of our unstructured data team, and so I get to meet and talk with customers that are struggling to, analyze large amounts of data. Also, one of the cool things I get to do is I'm on the Hadoop black belt team. And so, contrary to what I thought before I joined it, I don't get to do Taekwondo or any kind of martial arts like that. But I do get to travel around and meet with customers who are struggling to implement Hadoop and things in the big data ecosystem, and then also who are just starting out. So maybe these customers haven't seen the challenges just yet with it. I'm from Huntsville, Alabama, so I'm not sure how many people are familiar with that, but it's made famous by Warner von Braun and the space race. So pretty cool, pretty cool area. I'm part of a big data meetup, and since we have so many rocket engineers in that area, it's not uncommon to go to our big data meetups and hear somebody who's actually running analytics on a missile simulation or an insider threat application, and then also somebody just from a startup too. So really cool opportunities there. And then also I'm a Pluralsight big data author, and so I write courses and do courses around for people who are just getting started with HDFS and some of the other things in the Hadoop ecosystem. So what are we going to talk about today? So we want to walk through the analytics of things and figure out kind of, all right, what are we talking about here, and what are some of the business cases, and why is this, such a big deal? Definitely want to walk through the past, present, and future of streaming analytics and kind of see, okay, where we are, where we are as a community, where we've came from, and then kind of where we're going in the future. I've also got some recommendations that I want to give you and just share with you guys that I've seen, from meeting with different customers and just being, in the industry for some time. And then next, we're going to talk about the digital transformation. And so I would say that everybody at this conference and everybody probably in this room, the digital transformation is, encompasses a lot of things, but most of us in this room probably think that the biggest part is analytics, right? So, and big data. So we'll talk about that and how we're working through. So I want to talk about a couple of different industries, right? So, what are we talking about when we say the analytics of things or the Internet of Things? And so one of the industries that I've been thinking about is agriculture, right? So you wouldn't think of agriculture at first, but so my father-in-law, he is actually a hydroponic small farmer. And so, he's in agriculture, and, it's funny to hear him talk about some of the things that are going on and how it kind of relates to the things that I do, right? So some of the things that we talk about is being able to track different things. And so, we're really obsessed with food, right? I mean, you can't open your Instagram or your Facebook feed without seeing somebody that took a picture of, their food. And so, wanting to be able to track that, wanting to be able to, know where your food came from and know where you can track it from the farm is something that we're really starting to see in smart agriculture. Some of the driving behind this is, if you think about, recently we had an outbreak in a neighboring state of bird flu. And so it was really cool to see how they were tracking all of that and how, both states were kind of coordinating and communicating to all the small local farmers and even some of the larger farms, just to be able to coordinate and know how that works. And part of the driving force behind that is just think about how a recall works, right? So if you have a recall for an automotive in the automotive industry, it's a very substantial purchase, right? A car or your vehicle, and so you can kind of track that, and depending on how that recall is and how severe it is, you might get an email or a call from the dealership saying, hey, can you come in? We'll fix whatever that sensor is on your device, or maybe it's just a seatbelt. And so there's a long process to be able to track that. But how do you do that for agriculture, right? How do you do that when you might not find out until 7 days after, all your lettuce has been shipped out that there's been a defect with it. And then what happens if somebody had consumed it? And so, that's one of the things that we're starting to see is, they want to be able to track all this and be able to track it for recalls and just for informational purposes too. Another one is the equipment maintenance. I don't know if you guys have saw, but I think I saw in the last month where the most accurate GPS device is actually not by NASA, or at least they're not telling us, right? But it's John Deere. So John Deere can, has a GPS device that's accurate within an inch. And so they can tell you, where they're planting seeds, and, they can start to optimize some of that to be able to, decide and give information to farmers on where's the optimal place to plant their seeds, and, how different patterns and everything kind of correlate to, where their crops are planted. And then also equipment maintenance. And so being able to share equipment, but being able to also look for preventative maintenance on it. So, a combine and these tractors, they're not very small expenses. And so any kind of information you can pull off of it to, do any preventative maintenance, fix something before it breaks, is something that's gonna be really beneficial to the small farmers and the larger farms too. And then also the retail experience. So, back to talking about, our obsession with, being able to track our food and just kind of where we are, consumers want to be more involved too. And so, like I said, my in-laws, they started out just, doing hydroponic farming and, started branching out doing, other pieces just around farming. But, they ended up starting their own retail small market just because of, the influx of, buy fresh, buy local, And so, customers are wanting that retail experience, and that kind of goes back to being able to track some of these things, where we traditionally wouldn't, think there's going to be sensors on lettuce and some of the other things. So they're doing some cool things with, some barcodes and being able to scan those as they come in. Another industry that we're talking about, so smart homes. There's been estimates anywhere from 50 billion to 134 billion in the next 2 to 5 years for the market for smart homes. And so, the big one here is more efficient homes. So more efficient homes, helps the environment, but it also, helps us, as consumers to be able to lower our bill. So one of the purchases I've just recently made is the Nest thermostat, and it's really awesome. Like right now, I could change and, making sure, since I'm away from my home that, my air conditioner is sitting on maybe 80 degrees this morning in eco mode. So my wife, who's sitting at home, might not be too happy, but so we're able to do those more efficient devices, but it's also bleeding over too. There's opportunities there to tell us, what's the optimal time for us to maybe, run the dishwasher or, run your washing machine. That's going to help you as a consumer save money. It's also going to help out on the grid too, because, it's a lot easier to run some of these workloads, at night when a lot of people aren't using them. And then preventative maintenance. So just like we were talking about with the tractor equipment, think about in your homes. So as homeowners, the one thing that you hate seeing is that, hey, the refrigerator's out, right? It's a pretty big cost, or a hot water heater. And so being able to, know a device is going to break before it breaks, and being able to give you information on it too. And so that's really cool, just from the fact that whenever a device goes down, so whether it be your dryer or, your washing machine, it doesn't go down, at a non-optimal time when all your laundry's done, right? It goes down when you came in to use it and you found out, oh man, I've got to get all, got to run this load of laundry, or, your dishwasher. And so being able to have that information, it's going to help out the consumers, but it's also going to help out the manufacturers because it'll create more brand loyalty, right? And then safety and emergency sensors. This is by far for me, my favorite device in my house is my Nest smoke alarms. And so you're probably like, well, how cool, what's the coolness of that? So no matter where I've lived, whether it be in an apartment, whether it be in a townhome, whether it be, in my own home, the smoke alarms have always had their batteries go dead at like 2 a.m. And so there's been times where at 2 a.m. you're sitting there trying to figure out, one, is it the battery? Is it, maybe some dust that's in there? You can't get it to be, go down. And it's awesome to me that now, I have a Nest smoke detector that'll tell me on my phone when my battery's starting to go low, and I can also silence it so that it doesn't go off at 2 a.m. or if it goes off at 2 a.m. I can have like a 6-hour break. So those are all really cool things. There are a lot of safety and a lot of emergency sensors that we're starting to see with the smart homes. And so those are just two industries where we're starting to see, the analytics of things and the sensors. But kind of what does that mean for all of us in this room? Well, so Gartner's predicting that by 2020, we will have over 20 billion devices that are connected to the internet. All this is data that needs to be analyzed, it needs to be processed. But 20 billion devices, so if we say the population is 7 billion people, that's only really 3 devices per person. Who in here has 15 devices in their home connected to the internet? Okay. Anybody with 50? Anybody with more than 50? Okay, so a good majority of us said we had over 15 devices. Some of us had, closer to 50. I went up and counted. I thought I was in the 10 device camp when I was kind of walking through this presentation. I've got like 25 devices, and I don't consider myself on the cutting edge or anything like that. And so if we just look and we say, hey, maybe 15, maybe 1/4 of the population has 15 devices, we're talking more like 30 billion devices by 2020. So these numbers right here, these numbers could be very conservative. But what does all this mean from an analytics perspective and from a storage perspective? I said I'm from Huntsville, Rocket City, had to put one in. Houston, we have a problem. So we're talking 44 zettabytes by 2020. And so that's for all our transactional data, but that's also for the Internet of Things too. And so how are we going to be able to analyze all this data? What challenges are we going to see? I mean, we're still having challenges trying to analyze terabytes and petabytes of data, right? Is anybody not struggling with that to some extent? Okay, so what are we going to do when we get to a zettabyte, right? So a zettabyte is 1 billion terabytes. So let's talk about our architecture patterns for how we're going to deal with all this, right? So the next 2 to 5 years, seeing these 20 billion devices, maybe 30 billion devices, what are we going to do? So looking back at the past of streaming architecture, when I was first working in the big data environment, this is kind of the architecture we had. So I was working on a project, and it was our first project, and we were pulling off sensor data. And so we were pulling off sensor data of certain installations, and we had to be able to pull this data in on an hourly basis. But we also had to be able to pull in this data in an unpredictable fashion. And so we could go from anywhere from 25,000 devices to over 100,000 devices. And we didn't know how much information was going to be sent, right? Because it was all dependent on the user, whether it be a server or whether it be some other sensors that were on our installation networks. We had to be able to analyze that data. Well, this was before, we had Spark and we had, the streaming analytics platforms. And so when we used to do that, I mean, what we did is we were able to capture our data, and we would pull it into our loading zone here. Then we had to still ingest our data into HDFS before we could start running our MapReduce jobs and be able to pull it out. And so it was a real timing factor for us because we had to be able to pull these reports on an hourly basis and be able to pull analytics back on it too. And so we were, if we got behind with our ingest, if we got behind, with trying to run our MapReduce jobs in HDFS, we were behind the curve here, and it was deemed unsuccessful for us. And so really the past architecture, there was not really a streaming solution, right? And so that's kind of, where as an industry, Spark came out and Flink, and we've kind of moved, to where we are now. And so if we look back, or if we look now where we are with our present streaming architecture, back in that same application I was talking about, so we have our sensor data that's coming off the network, and as that data comes in, we can move it into a storage system here, like Kafka, and be able to pull in our data. But then we still are able to use our real time. So if we wanted to use Spark streaming down here, we could analyze that data, those data points that came in every hourly that we were trying to pull insights off of. And maybe it was data that we needed to be able to analyze in real time. But then you still have your batch processing, right? You still have maybe your historical data that we wanted to be able to analyze it. But we really have 2 different systems here. So we have our batch system up here, and then we have our speed layer here, all pulling into our insights. And so as we start to look at this, I mean, we have, our different devices here. So, we have some of our data in HDFS and some of our data in Kafka. And we also have our DR environment here. And you start to see it, this is really a Lambda-based architecture, right? So we're still trying to analyze 2 separate systems. We're still supporting 2 separate code bases. And there's a lot of deduplication. There's a lot of deduplication of our data as well, too. And so this is kind of where we've started talking about, being able to process data in a more of a Kappa-based architecture, right? And so what we have here is as our data comes into our queuing system, then we're able to do our processing here, we're able to do our distributed search, be able to pull our insights. And so what we're really looking for is we're looking for this Kappa-based architecture, but being able to analyze our data and have it in our storage layer here and really be able to abstract away that storage. And so not have to worry about where our data is going to exist. Just know that, we're going to process our data with whatever tools we want. So if we wanted to use Flink, if we want to use Spark, if we want to use our distributed search, we just know that our data has been captured here and our data can auto-tier here. And so this is where we start to see technologies like Pravega. And so what is Pravega? So Dell EMC released Pravega to the open source community May 10th. And so it's a new abstraction layer for streams. And so we have an architecture diagram here, but you can see that it abstracts away all the storage here. And so as your data comes in, you're able to have your streaming middleware here. So if you're using Flink or if you're using Spark or some kind of distributed search, you're able to access your data and run your processing here, but then also not have to worry about where your data is going to exist. And so as your data comes in, you can have what we would call our tier 1 storage, so your fast data that comes in is here, but it's also going to be able to auto-tier that archive data off to your tier 2 storage, all without you having to worry about it. So, as your streaming applications here, and as your developers work with Flink and Spark and some of the distributed searches, you're not having to worry about where your data sits, and you can still run your MapReduce jobs and your Spark and your Flink jobs. And so it's coordinated scaling too. So we talked about the devices, going up to 20 billion, but we want to be able to scale those devices as well. And so you want to be able to know that, as more data comes in, you can start to scale it. And so that's one of the things that we're seeing as well, is just being able to auto scale that. So being able to scale as much data as we need. And so what are some of the architecture recommendations? So some of the things that I've seen, talking with some of the customers, is timing is everything, right? So when we're talking about streaming analytics, you want to know what the time value for your data is to insights. So like we were talking about with, being able to pull data off of, for a recall in agriculture. You want to be able to pull that data off, but it doesn't make any sense if you're able to analyze the data and you're able to pull it, but that you can't use the data. So, if the product's already being consumed. So you want to be able to know what the time value of that data is. And so if you know the time value of that data, then you can decide how fast you're going to process the data. And this is where we start seeing, where we started talking about being able to stream and process that data in real time. And so the next recommendation that I've seen is we want to ensure that our systems can scale independently. So you want to make sure that you can predict the growth in an unpredictable way, right? So if you can't predict what the growth is of these applications, then you have to have systems in place that are going to allow for that to scale and allow for you to be able to take in more data points. So one of the things that we start to see is that, when I was on the customer side and, we had a big data project, the first thing that we started seeing is as our Hadoop environment started to grow, we had other business units and other, components within our business that were coming to us and saying, hey, can we analyze some data? Hey, I've got 10 more terabytes of data, or 5 more terabytes of data, or they just might come to you and say, hey, I have a lot of data. So you want to know, how much data they're bringing, but you also want to be able to scale it. So has anybody kind of seen that where, as you guys, as people start seeing that your system's working, they come to you and say, hey, I have a lot of data, can we analyze it? Does that happen to a lot of people? So that's why you want to make sure that you can scale these systems, and these systems can scale independently too, right? So if somebody brings you some data and you want to be able to, analyze that data in more real time, maybe you want to be able to independently be able to scale that processing of the data versus just your capacity. And then the next one is the life cycle cost of your data. And so, back to what I was talking about, people will come and, you'll have opportunities to analyze, 100 terabytes of data or 10 terabytes of data from different internal business customers. but you want to know what that cost for that data is, right? So what's it like from a product perspective? And so this is really where we start to see and start to say, it's more, more mature environment for our big data systems, because we can put a value on how much that data is. And so how much more of a cost is it to bring in that data? And then what's the value of the data and the analytics that we're going to capture back on it? And so this will help us kind of, start to be able to, take on new projects and be able to analyze new data for, different people within our internal customers. And so we're really starting to look at it as data as our product, in these systems. And especially when we're talking about streaming applications, right? Because streaming applications, as we're starting to pull that in, it's, really process intensive, and how much data we want to be able to capture and keep in streaming environments. Sometimes you want to limit that, but you want to also be able to scale that as well. And so let's talk about the digital transformation. So, 2017 is the year for the digital transformation. There's a lot of different components about the digital transformation. Like I alluded to earlier, I think most of us in this room would agree that the digital transformation, the biggest component for us is probably the analytics of the data and how we're going to analyze that data to be able to help transform our, our companies and our organizations that we support. So whenever I think of transformation, I think of butterflies. And the reason I think of butterflies is I have a 5-year-old daughter. When she grows up, I've asked her probably 10 times what she wants to be when she grows up. She wants to be a butterfly. I was like, no, you want to study butterflies? Do you want to be a professor that teaches butterflies? Do you want to teach biology? No, she wants to be a butterfly. And so she's 5 years old. I can't convince her otherwise just yet, but we'll work on that. But that's what I think of when we think of transformation. For a butterfly to transform, you go from a caterpillar to a chrysalis, and then out pops this amazing, beautiful butterfly. Well, that's in nature, right? Nature's had some time to perfect this. Nature's had a lot of time to get it right and to practice it and to fail too. And so, but when we look at it in the data center, we don't have as many opportunities to fail with it, right? And then we haven't been doing it very long. And so that's where my role at Dell EMC and being part of the Dell EMC family, we've seen where we can help, right? So we've been part of digital transformations. We've been helping our customers with digital transformation, so we understand it. And so one of the challenges with streaming analytics, we've talked about it, everybody's seen the slide where it's, the different ecosystem of, just in the Hadoop environment and in the streaming too, right? So we have all these different applications to do different things, and how do we make those interconnect and work together? The next thing is what we talked about, part of a challenge in streaming analytics is the real-time business value. How do we pull that insights back? How do we make sure that the insights that we gather and we can act upon, right? So if you're trying to, if we're trying to make give a coupon incentive to a customer, from their mobile app, we want to make sure that we do it when they're in the area where they can use it, right? It doesn't make any sense if, we weren't able to do it, while they were close to our point of sale. So, if they get the coupon after they've already gotten home, that value's not really pulled. And so that's what we see and what we mean by timing that. Then also the siloed data, right? So having to support, a real-time work stream, and then also your batch work stream. That becomes two different silos of data, but it also becomes two versions of code that we have to analyze, right, and have to maintain. Production applications are hard when it's just one code base. Adding on a second one just adds another layer of complexity, adds more testing, more pieces that we have to do. And then also, we said, in the next 2 to 5 years, to see 20 billion different devices come on, maybe 30 billion devices, to see 44 exabytes of data, we're going to need not just, I've been saying scaling, but we're going to need extreme scaling. So we're going to need to be able to analyze that data, but we're also going to need to be able to store that data too. So this is where we started talking about Pravega, but we really see the industry having to change the paradigm. We really have to change and build our storage systems from the ground up to be able to analyze this data. So with Pravega, one of the things that we've created with after we released Pravega to the open source, we have something called Project Nautilus. And this is a high-level architecture of Project Nautilus. One of the cool things you can see, come by tomorrow at our booth, and we'll actually have sensors set up. And so we'll have sensors set up. We'll actually be reading your brain waves. So you can put a sensor on your head, and what we'll do is we'll show you different pictures, and we'll be able to pull that data off that device, be able to analyze it. So think of your, this is your IoT device. So these sensors right here, as the pictures change, your brain waves and the sensors are going to change too. And so what we'll do is we'll actually analyze that data real time and show you, how Pravega works, but how Project Nautilus works, right? And so we'll be able to analyze that data, and you'll be able to see it, all in a diagram, and see how you react to certain different images on the screen too. And so when we talked about Project Nautilus, just know, as we were talking about the storage and being able to abstract it away, that data can still exist in HDFS and your object. And so being able to tier that data down too. So we talked about analyzing that data and knowing that more data is coming in 44 zettabytes of data. So you need to be able to tier that data off and be able to tier that off to different storage layers too, right? Because not all data is going to cost the same, and not all data is going to derive the same value, right? And then being part of the unstructured data team, I've spent a lot of my time talking data lakes. And so at Dell EMC, we have two different data lake options. And so one is Isilon, and Isilon is our file-based data lake. And so Isilon supports multi-protocol. So if you think about your data coming in, in a Windows environment through SMB or coming in through NFS for your Linux mounts, you can be able to analyze that data because we analyze that data. We analyze HDFS as a protocol. So data comes in, data's analyzed in Isilon through HDFS. We get 80% storage efficiency. So from an Isilon perspective, we use forward error correction, just like some of the updates that we've talked about with Hadoop 3.0, and that's what gives us the 80% storage efficiency. So no more worrying about master node high availability and data nodes all integrating together. With Isilon, each node is a master node and a data node as well. And so as your data comes in, you don't have to worry about the triple replication. Your data is analyzed, and you're able to use Isilon for your data lake. And so this prevents you from having to create these data silos where you just have, data, you have just your Hadoop environment here, but then you also have your business and your other applications too. And so this brings in that whole data lake opportunity. For our object-based data lake, we have ECS. And so ECS is our scale-out cloud storage leader. So it supports S3, Swift, and Atmos. And it offers the opportunity to analyze your data in an object platform too. And so it supports HDFS as a protocol as well. And so choosing your Hadoop partner. So, how many people have their environment built or have it all ready to go? And so we have part of our blueprint team is what we call our data analytics solutions. And these are our ready-made bundle that are certified with either Cloudera or Hortonworks. And these are certified all the way from the servers, the storage, the networking, the automation. You don't have to worry about how you're going to set up your environment. You don't have to worry about, is this integration piece test? So each one of these are custom made for whichever Hadoop partner bundle you want. And then we also have our solutions too with the Isilon shared storage. And so these are blueprint devices. These are blueprint certified configurations that have gone through the integration testing and tested with each different version. And then next is our Analytics Insight Module. And so it's engineered for speed, but it's engineered to be able to take some of the guesswork out. So how awesome would it be for your data scientists to be able to come in and say, hey, we want to set up and we want to build an environment. We've already got our Hadoop distribution chosen. We've already want to abstract away some of the storage and some of the other pieces, but we don't want to have to handle the data governance and the security. We just want to be able to set up that sandbox and that test environment and be able to deploy that out for other users and other data scientists to be able to look at the data. And so that's where the Analytics Insight Module comes in. And so we have that set up. We have a way for you to see that here at our booth. And so definitely want to check that out. And so we were talking about people setting up their environments and kind of where we are from streaming. But just in general, some of the numbers that we've seen is 44% of organizations, they're struggling to approach big data. They're struggling to approach how they're going to deal with it. And so it's a complex ecosystem, right? It's not just about your infrastructure. It's not just about, is everything going to integrate together? But you also have to do your analytics, right? Because that's what it's all about, is being able to pull those insights. And so at Dell EMC, we've been a part of that. And so we've got different solutions and different ways to help it. But we can also help out with the partners and the security and the services. Because it's not just about setting up your environment. We also have to secure those devices, right? We have to secure your environment and be able to test and be able to have the partners that are involved in the ecosystem. And so one of the things that you'll hear tomorrow, so Bill Schmarzo, he's our CTO for our services, and he heads up a group that does big data vision workshops. And these are 2-week engagements that actually help customers that are starting out, or maybe they have their Hadoop environment set up. But what they do is they focus on the business value of solving big data problems. So it's not so much about setting up and designing out your architecture, which we do that too. But this is about finding opportunities to get quick wins. And so one of the things he always says and always talks about is anything over 6 months, that's a science experiment. So this group, their whole engagement is to come in and be able to identify 1 or 2 use cases that can be implemented, tested out, and analyzed to bring back real value in your corporation. And so that team is here too, and so you can see and talk with those guys. We have a lot of customer success stories. I will say one of my favorite ones is an internal one. So with EMC, we had lots of different data. So from an EMC perspective, we have a lot of different tools and storage devices that we have and customers have out in the field. But we were having trouble trying to pull that data and try to be able to analyze certain data. And so what we had different silos of the data. And so what we used is we used our data lake storage device to be able to pull in all our data and be able to aggregate all of it in our own data lake so that we could share that data and actually analyze that data. And so one of the things that we created was we actually created a product out of that was able to called our 360 customer device. And so we actually use that now internally and give access to our customers for that device on all the things that are going on, all their devices to track and know where they are, and there's some of the services with it. So it's a really cool story, and it just shows that Dell EMC, we do this. We're part of the big data community, but even we have challenges too. And so a lot of times it's we're able to pull in and analyze that data just as well. So check us out, booth 100. We're here. And then I've saved some time here at the end. Does anybody have any questions? If anybody has any questions, I think they're asking just to move to the middle aisle here. So is there anything?
Hey, so I was looking at your slide for the future, where you were comparing the present architecture with the future architecture. And one question that came to my mind was, we have a split sort of a thing where we do the hourly processing, which is based on Spark streaming. But at the same time, we have batch processing sizes, which are huge, which we run on monthly data, and we have monthly data models. So how does the future architecture come into huge batch sizes, and how do you plan to handle that size of data with streaming applications like Flink or Spark?
Yeah, so one of the ways is, so we were talking about the data coming in, so kind of what you're saying, my assumption is that the batch processing that you're doing for those larger jobs, that's probably something, on some of the historical data, not running you don't need to pull the insights right then. You're okay with it taking a day or 2 days or however long that process does. Well, so if you look back to the slide, so we talked about having the tier 1 and tier 2, the storage, and Pravega is going to handle on how to tier that data. So what would happen is you would still interact with Pravega, but most of what you're talking about would probably be on your batch jobs or mostly your catch-up reads. And so you'd be able to run your catch-up reads, and that would be pulled from your tier 2 storage. Once again, it's abstracted away, so you're still able to use the APIs there. We've got, and we actually have, at the booth, we have a couple different other slides that go in a little bit deeper too, so definitely come by and check it out. We can kind of show and walk through that too.
Can you share some of your experiences with Flink and long-running windows, like a window over a period of 1 day or 1 week? Have you encountered that kind of an application in your experience, and how did Flink behave? Because I saw you are using Flink in your architecture.
Yes. So in in Project Nautilus, we actually in the booth, what we have is when we put the sensors on, we're actually using Flink, but it's pulling for real time. But come by and we'll talk a little bit about some of those. You're looking for some benchmark numbers kind of on the 1 day and 2 day windows. Come by and let's see if we have some of those just yet. Thanks.
Are you going to be implementing any sort of tie-ins to the Edge X platform, the IoT pass that Dell released and open sourced? Is there any sort of tie-in, any sort of strategy around bringing more or less that, edge analytics into this type of an analytics framework?
I don't know that it's, from a Pravega perspective, I don't know that that's on the roadmap, kind of what's released. I'm sure internally there's probably some conversations going on, but nothing that I know of or anything that I can release. Good question, though. Anything else? Well, thanks, everyone.